A warm greetings to one and all. In this session, let's learn about exception handling. Topics to be covered in this session are introduction to exception handling, standard exceptions, types of exceptions, and finally, let's check out the exception level. As a part of introduction, we all know that it is very rare that a program works correctly for the first time since it may have some errors. The two most common type of bugs are logical errors and syntactic errors. Logical errors occur due to poor understanding of the problem and solution procedure. Syntactic errors arise due to poor understanding of the language itself. The errors can be detected using exhaustive debugging and testing procedures. Sometimes we may come across some peculiar problems other than logic and syntactic errors. So such errors are called as exceptions. Exceptions are runtime anomalies or unusual conditions that a program may encounter while executing. Examples for exceptions are divide by zero, array index out of bounds, and so on. When a program encounters an exception condition, it is important that it is to be identified and dealt effectively. C++ provides built-in language features to detect and handle exceptions, which are basically runtime errors. Next, exception handling can resolve the following types of exceptions. It allows the program to continue executing, or it notifies the user of the problem, and it may terminate the program in controlled manner. It makes the program robust and fault tolerant. The needs for exception is it may detect and report an exceptional circumstances. It also separates the error handling code from the normal code. The functions and methods can be handle any exceptions they may choose, and it may also group the error types. Now let's learn about standard exceptions in C++. So the first base class or topmost parent class is exception. So exception is the parent class of all the standard C++ exceptions. So it has the following subclasses. Let's check out one by one. The first one is bad underscore alert. So this exception is thrown by a new operator that is due to insufficient memory. So the next comes bad underscore cast. So this exception is thrown by dynamic underscore cast that is during invalid type conversion. So next bad underscore type ID. So this exception is thrown by type ID due to invalid type during the runtime. So next bad underscore exception subclass. So this is useful device to handle unexpected exceptions in a C++ program. So next subclass is logic underscore failure. In turn, it has many subclasses. That is the first one, domain underscore error. So this is an exception thrown when a mathematically invalid domain is used. So the next subclass is invalid underscore argument. So this is thrown due to invalid arguments. So the next comes length underscore error subclass. So this is thrown when a 2-bit string is created. So finally, out of range subclass. So this can be thrown when an attempt is made to access an element outside the valid range of an indexed container. Container may be stack, queue, array, or a list. So the last subclass is runtime error. It has various subclasses, namely overflow underscore error. So this is thrown if a mathematically overflow occurs. The next subclass is range underscore error. So this is occurred when you try to store a value which is out of range. So the last subclass is underflow underscore error. So this is thrown if a mathematically underflow occurs. So hope you are clear on types of standard exceptions in C++. There are two types of exceptions, namely synchronous exceptions. So it may occur during the program execution due to some fault in input data or technique that is not suitable to handle the current class of data within the program. So a few examples for synchronous exceptions are errors such as out of range, overflow, underflow, and so on. So the next type is asynchronous exception. It may be caused by events or faults unrelated to the program and beyond the control of the program. So examples are errors such as keyboard interrupts, malfunctions of hardware, disk failure, and so on. Exception can occur at many levels. So it may be in hardware or operating system level. For example, arithmetic exceptions such as divide by zero error, memory access violations such as stack overflow and underflow all comes under hardware or operating system level exceptions. So the next is language level exceptions. So here it may be due to type conversion, that is illegal values, or it may be improper casting of a data. Next, bounding violations, that is it may be due to illegal array index out of bounds. Finally, bad references, which is caused due to null pointers. So these types are due to language level exceptions. The third level is program level. So this can be resolved by using user defined exceptions. Thank you all.